Welcome back. This is part 2 of my pick and place work here in my lab, and we'll go ahead and run through some of the things. What you're going to see here is this is one of the more complicated video shoots I had to do. I have a camera on the platform, and then I have a camera facing me. Then I'm doing a screen capture on the LinuxCNC desktop, and we'll see how it goes. A lot of merging going on. But the first thing I'll do is we'll go through and I'll show you what's going on the screen. We'll go through a homing cycle, and then I'll kind of show you the speed of the machine, and then we'll go ahead and get it lined up. Okay, so first thing we want to do is we need to home it. So you can see over here, this is Linux CNC. I'm running version 2.7.7. And it's this is the USB camera display over here, and this is a little Python code I wrote at the bottom here. But you can see that none of the axes are homed. When they are homed, there's a little star over here. So what we'll do is we'll go ahead and zoom this over near the home switches, and then I'm going to go ahead and do a homing on the y-axis and the x-axis at the same time, and we kind of crawl into the limit switches. Now Z and A are I have Z set to the camera height. I'll go ahead and home it right there and zero that, and then I have the A is, it doesn't really matter where A is. Okay, so that's, you can see that these two stars showed up over here, and I'll go ahead and home Z and A. So what that lets us do is we're able to use the MDI now to actually command the machine to move out. So I'll go ahead and do that. So I know that the one of the fiducials is at X6, Y6. Okay, so there's one of the fiducials right there. That's the lower left-hand corner one. And I'll show you something first, so you can kind of see where we're kind of in the ballpark. I'm going to show you the speed of the movement of the platform. So I have an exercise routine that actually does an hourglass pattern on the board about 5 times, so you can kind of see what the speed of this thing is. Okay, so we're running through the thing right now. And I did go and tweak this a lot. I played with LinuxCNC to set the acceleration and the maximum velocity so that I wouldn't miss any steps. Okay, so you can see there, I went back over here to, I don't know where we ended up. Oh, we ended up back up at 0, 0. So if we go over here and go back to X6 and Y6, we're back on the fiducial number, the lower left-hand corner fiducial. Now the other fiducial is at X194, Y94. I mean, if you come in here and type that in, and oops, no, Y94. There we go. Okay, so here's the other fiducial right there. Now this is after a calibration run. I did get the, I'll go ahead and show you what I ended up doing there, because it's kind of critical to how this actually runs. I read through, my early experience with CNC is running a Gerbil board on a couple of other projects. And LinuxCNC is a much more sophisticated program and a lot more support for different G codes. And it's really difficult to get the board and actual positioned aligned with the platform. But fortunately, LinuxCNC has a provision for your workpiece, which is our board, to be rotated in the Z-axis, and I've already got that set. If you look over here on the interface, I'm on G54 workspace here, and R is set to minus 0.190, and that sets an angle. So the workpiece is actually skewed a little bit clockwise, just a little bit, and that little bit is enough that if you were to place it without that, you'd completely miss the parts. And I'll go ahead and turn that off and show you what we would actually end up getting. So we turn that off by using a G, I don't even remember what it was. It's up here somewhere. It is, I think it's G10 L2. Where the heck is that thing? I was just messing with this. Oh, this is not good. Oh boy. Well, let's try it's G10 L2 P1 R0. Okay, so you can see that this G54R changed to 0. Now let's go back down and kind of see how tilted the board actually is in the platform. So if we go down to X1, Y1, I'll kind of show you how this works. So what I'm going to do is I'm going to inch my way over to the edge of the board. There's a ground plane on the top. You can kind of see it right there. And the edge of the board, the edge of the board on this particular board, depending on how you get your boards made, they might be scored and broke, or they might be routed. This particular board is routed, but some of the boards I have really have a crappy edge on this one side. So you really want to trust something that actually went through the photolithography process, which in this case is that ground plane. So what I'm going to do is I'm going to inch down to that ground plane. I'm going to millimeter down to that ground plane and get us lined up right on the corner. And then what I want to do is I'll go ahead and zoom out to the far side of the board, and we'll see just how far off the board is out of rotation. So if we come back over to MDI and we do an X about 195. Okay, so you can see that the board is actually rotated a little bit. It's rotated in a clockwise position. So what you can do, what I did was I moved over 194 distance, and then I measured this distance here. In Y, we started out at 0.7. That's where we started out. And then if you measure X and Y and then take the arctangent of that, you can put that value in. And it turns out for the board that I have in there now, its orientation, the way it's rotated, works out that the angle is minus 1.19. So I'm going to change that again. I'll put that back to where it was. It was minus 0.19. Actually, it was something else. Oh, it's on my calculator. 19 is going to be fine. 190. Okay, so let's go do that X move again. So we're going to go back over, and we'll go back to X equals 1. Now, what that angle does is it LinuxCNC will recalculate all your X and Y positions based on that angle. So I'm going to go ahead and get positioned back down, and I'm going to work my way back down to that corner again. Okay, so right there we're on the corner. So now I'm going to go back at the X195, and you'll see that I'm right on the money. I hope this makes sense to you. Okay, so you see that we're now right on the edge. Now what it ended up doing was it moved Y at the same time as it's moving X. You can't see that here because it's so small. The fact that offset, the G2, what did I say it was? The G10 L2 offset exists in LinuxCNC, makes it really accurate to get this board in there. Then you have to be anywhere near level. I could put this in at a 45 degree and this would all figure it out. I spent about 2 hours playing with that to make sure that worked, because otherwise I was going to have to resort to something else. Now, OpenPNP is a project for an open pick and place machine, and they use OpenCV, and they're able to locate the board by looking at the fiducials. And I started looking at how OpenCV actually finds those fiducials. I've never done anything really with OpenCV, but in the future what I like to do is to go and incorporate that same approach over here. Then it doesn't even matter. I could just slap the board down however I want. And kind of it'll go find the fiducials and get everything lined up. And then OpenPNP actually then modifies all the parameters, all the X and Y positions for everything. But we'll just we'll stick with this because you'll see that these results are actually fairly good. So now that I've kind of monkeyed with the coordinate system, I need to go realign it. So the way that I found that works the best is if I pick the upper right hand fiducial and do it on the LinuxCNC. It's called touch off operation, and I set that fiducial to 194. So I'll go ahead and do that. So if I come over here and I type in X 194, Y 194, okay, so you can see that I'm off a little bit. This is all fine. This is how I ended up getting this thing calibrated. So what I end up doing is I inch over to the center of that fiducial. And you can see on the VLC screen that I have a crosshair. VLC allows you to overlay a transparent PNG right on top of the video, which is really kind of handy for this situation. So right there, that fiducial is really at 194 or 94. So I'm going to do a touch off here on X. And I'm going to make this 194. Oh, crap, that didn't work right. I touched off the wrong one. Well, that's all right. I touched off 57, which I'll talk about in just a minute. Come on. 194. You can see that this up here changed to 194. What touch off does is it applies an offset such that your X and Y positions are set to whatever value you want them to be. So it kind of changes the offset so that where you are is where you touch off where you actually are. This is also pretty handy. So we're at 94 here. Okay, so now we've kind of calibrated the machine because we tweaked that angle, and so now we need to check the other fiducial and see how well we did on that. So if we come back over here, our other fiducials at X6, Y6. Okay, you can see that we're a little bit off. This is actually fine. The surface tension of solder parts, for fine pitch parts, this probably is not that accurate. But for all the 0603 parts I have, it's going to be fine. So I'm going to stop this here, and then I'm going to pick this up, and we're going to go through and run through the inspection process and some other things. So I'm going to just hold on. I'll be right back. All right, I'm back. Let's go look at some other aspects of this pick and place machine. First thing, people might want to kind of get a size of these parts for people that don't really have a grasp of how small they are. So I stuck a penny right next to R53. So I'm going to go ahead and zoom over there. And the penny is huge. You can see the L in Liberty. So if we go to R53, of course the L moved off. Let me move it. See if I can get it back on camera here. Okay, there it is. So the pads are about the size of the L in Liberty, which means that an 0603 part is really about 1.6 millimeters by 0.6 millimeters. Kind of losing my voice. Sorry about that. All right. Well, down here, like I said, I was running LinuxCNC version 2.72, and I've written a Python program that actually does my parts management as well as controlling LinuxCNC. It's a modification of that. If you go back and look at some of my old videos, there's a thing in there called a MyPOS DYI CNC or something like that. It was an old piece of junk machine. I don't know if you can see it or not, but it's on the floor back behind here. That was a horrible machine, but I did actually end up placing a board with that. I took that code and modified it to run with LinuxCNC, which is a much better way of doing it. That thing uses a Gerbil board, which has a single serial port, so one process can attach to it, and then everything else needs to attach either to that process or some other way. It's kind of a, well, let's just say LinuxCNC is much more graceful. So I wrote a little Python code, and you just basically kind of connect to the running process, which I think probably uses shared memory. And it passes G-code back and forth as well as status information. So this code you're looking at down here is the parts management as well as manual control of the machine itself. What I can do on there is tell it to go seek to a particular part on the board, and I'll go ahead and do that now. Let's just first go back and check the registration of the fiducials. So those are JP3. So I can say go to JP1, or JP1 is the bottom right corner, bottom left corner, and JP3 is the upper right corner. Okay, so that we kind of see that we're still pretty close to where we need to be. Now with this program, you can do visual inspection per part, or you can look at all the parts in a particular by particular value. So what you're seeing down below here is the parts database that has not been placed yet. It keeps track of which parts have been placed and which ones haven't. So there, like if you look at this row right here, this 10K, it looks like there's about 10 parts on there, R53, 54. Now I can go seek to any one of these, like R87, and it'll go right to the center of that part. Now it's oriented vertically, so you can't really see the silkscreen label. Let me find a part that's horizontal. C1. Okay, so here's C1. You can kind of see where our crosshairs are right in the center of it. The lighting in here is pretty poor. I'm relying on the camera's USB lighting to actually do something, and it's kind of illuminating poorly. But you can see that we're right on the money. So I'm going to go zoom around to some of the corners. The upper left corner is R91. Okay, so there's R91. The bottom left corner one is D1. And then the upper right C16. So I'm basically going around to all four quadrants of the board, and the bottom right is D24. All right, so the reason why I'm doing this part by part is because when my workflow and I'm working on prototypes is I don't want to populate a whole board. This particular pick and place machine also does solder paste, and so I can selectively place parts on the board that I actually want to test. And I can either solder those on with my toaster oven here, my reflow oven, or my handheld air rework station. And you know, in production, you would go ahead and make a screen for the solder paste and swipe it all on at once with a wiper. But when I'm at this level, I actually want to check out each individual circuit one at a time and verify its operation, you know, before I actually make a whole board. This program, the way it's set up, is designed for that. It's not really designed for production runs. Although, you know, you can do a production run, it's a little, you know, it takes a little bit more. It can do that, but for now, what I'm really interested in is placing individual parts from sub-circuits on the board. So by doing that, you need a couple of things. You need to be able to select which parts you want to put the solder paste down on and which parts you want to place. So let's say I'm going to do those 10K resistors. There's 11 of those right now. This program, like I said, controls the solder paste as well as the camera, and the pick and place head is all on one single platform. And the way I'm doing that, implementing that, is I'm using different workspaces. So I'm using, let's see here, G54 is the camera workspace. G55 is the solder paste head. G56 is the pick and place head. 57 is the first row of parts. And by doing different coordinate systems, I can, say I want to move the pick and place head to a particular pad. I can just change the coordinate system and go there with the XY coordinates, and I don't have to do any of that math. LinuxCNC figures all that out for me. So what we'll end up doing is we'll go and I'll kind of show you how we would end up putting down the solder paste for those 10K resistors. So if you hit an S down here and I type in, well, we'll do one resistor first. We'll do let's do R76. So what this is going to do is, I'm still in the camera coordinate system, so we're really just checking that the positioning is working right. So our camera is going to move over the two pads and mimic the operation of actually putting the solder paste down. Now the solder paste is a syringe, and I have like a controller here that puts out a specific size of blob with compressed air, and it squeezes it out. And so the point of this is that we move over to the right position, we turn the compressed air on for probably 1/10 of a second, little blob comes out on the tip, and we move down and place that right on the pad. So we'll go ahead and do R76 now. So there's one pad and there's the other pad. So you got to see that it moved to both pads. So let's go and do let's say we wanted to do all the 10Ks at once. So there's 11 of those. So we can say solder 11K parts. And what it's going to do is cycle through all these parts right here. And it's going to hit all those pads for all those parts. Well, it should have. Here we go. It's a 10K. Okay, so there's R76. And the way it hunts around for these pads is it actually goes and finds the closest pad to where it is, and it starts at that location. That kind of improves the speed, but it's working its way around the board, and it's working its way through all those resistors and putting solder on each one of those pads. And you can kind of see that we're getting, somewhere near the center. It's definitely better than I would be able to do by hand. So there's 11 of them, and down in this bottom window, it's actually telling you the status of what it's doing. So when it gets done here, what we'll do is we'll go over there and we'll set the coordinate system for the parts itself. Now the parts are over, in the feeder tray. So what we need to do is go over and set the 0 point for my 0 part in my tape. So come back over here to manual control, and we'll zoom over there. I get on continuous here. So what we're going to do is go find the parts, if I can here. Where am I? Somewhere along in here. There they are. Okay, so there's part number 1. So what we're going to do is we're going to actually set the touch off on part number 1. Actually, part number 0 in our list. So we come in and we're going to set the resolution down a lot smaller. And we'll sit right on number 1. Now I did write some numbers on that tape. It's kind of, you can't really tell what they say, but here's a 1 right here. Let me well, you can figure that out. There's a 1, number 2 is over here, and 3 and 4 and so on. These are spacing of 4 millimeters apart. And what I'm doing is I'm using G57 for that. So we're going to do a touch off right there in X on G57. And we're also going to touch off on Y of G57 at that 0 as well. So what that's going to do is when we switch to G57, we want to go to 0, 0, it's going to go right to that part. We want to go to X4, it's going to go to the next one. I can show you that manually right now. So we're going to switch the coordinate system G57, and then we're going to go, we'll do a speedy go, and we'll go to X4. And you see there's part number 2, X8, There's part number 3, etc. All right, now let's go do a run of, well, we're not actually going to put the parts down. We're just going to show you what it's going to look like. So let's say I wanted to go ahead and place those parts. So I have the 0th part in the array located, and it's going to step through each one of those. It's going to place the part, go increment by 4 millimeters, and go find the next one. So let's go give a run, and you can kind of see how fast this is going to do. Now I have the dwell time set for when it picks it up to letting it down at about a 1/4 of a second, so it's actually pretty fast. When I actually get this running, I have to tune up the vacuum and the motion of the z-axis in order to get this to work right, but you'll get the idea. So let's go. We're going to come over to my Python code, and we're going to say place, and let's place. We'll just place one part for now. Place R94. So what it's going to do is it's going to go grab the first part out, and it's going to stick it in 94. Now, if you look down here, what's happened is the database management system figured out, oh, we placed that part, so it pulled it out. So now we only have 10 10K resistors to do. So let's go ahead and do the rest of them. So we'll say place all the 10Ks. So it's going to go over and grab one, and it's going to go and it's going to place it there. And you can see we're really going pretty fast here. And you can see the countdown here on the R10s. We have 5 to go. And at the status line up here, it tells you where it's going to place it. Now at the same time, the z-axis will be rotating them to get them in the the right orientation, either horizontal or vertical. This is kind of where seeing LinuxCNC really shines. It's really quite efficient at doing all this. So there we go. It placed all the parts, and you notice that it also removed the 10K resistors out of the list. All right, well, there we go. It's there's a few more things to work on here. The second parallel port that I found a card for is going to run a relay rack as well as interface in my e-stop switch. So the relay rack is actually going to switch on the vacuum line for the pickup head, and it's also going to exercise a kind of a foot switch interface for the solder paste dispenser. And then I'll also have a relay in there to actually turn on some working lights for the platform here. I got some LEDs that I want to put in here because the LEDs that are in the actual microscope USB camera are really quite harsh. And what I do want to get down to doing OpenCV to do this recognition. I think this is going to work for 0603 parts. I need the OpenCV to actually find the centroid of when I want to put ICs down, because they come in trays, but they're a lot finer pitch, and so I need to actually find the center of that. A lot of CNC machines use an up-facing camera and a down-facing camera. I have both of those cameras now, and I'll be able to get things lined up a little bit differently. But for now, this is going to work just fine. I'll be able to place the majority of these parts are resistors and capacitors, probably about 140 of those, and I'll be able to place those pretty quickly. And while it's working, I can actually load additional components in the feeder tray. And all I got to do, if I want to place, like say 1 microfarad capacitors, I can just put that tape in there and then zero it out and place all those at once. Okay, well, that's it for now. Thanks for watching. We'll pick it up again after I get the rest of this wired up, and we'll go ahead and show you what placing parts actually looks like. Okay, have a good evening.